This video will work through problem 8.3 from Gapenski's Healthcare Finance, 6th edition. In problem 8.3, we're presented with the budgets for Brandon Surgery Center for their most recent quarter, and it's in thousands of dollars. And so the chart I've copied out from the problem. And so part A says, explain how each amount in the flexible budget was calculated. And they give us a hint to examine the static budget to determine the relationship of each budget line to volume. Okay, so what do we have here? So we've got number of surgeries. So we have static number of surgeries, these number of surgeries, flex number of surgeries, and actual number of surgeries. So static, of course, the static column in total, but the static number of surgeries is the projection of the number of surgeries that we think we're going to do at the beginning of, in this case, the beginning of the quarter. So at the beginning of the period, whatever that is, whether that's a year, quarter, month, week, whatever, the static is what we think is going to happen or our expectations about the future. Actual is what actually happened during the quarter. So they thought they were going to do 1,200. They expected to do 1,200. They actually did 1,300. Now, what does this mean for flex? Well, remember, static is our price expected times our volume actual. Our actual is our price actual times our volume actual. Sorry, price expected times volume expected. Price actual is price actual times volume actual. And then flex is our price expected times our volume actual. So if we're just strictly talking about volume, which is what this first line is the number of surgeries, then we're going to ignore price, price, and price, and we're going to have our expected volume, our actual volume, and our actual volume, if we're strictly talking about the drivers. So that's why we have 1,300 and 1,300. It's because we are looking at the actual volumes, right? Both under flex and actual. And then we're looking at our expected volume and our actual volume, expected volume for static, actual volume for flex again, and actual for actual, of course. Then revenue at 2,400 is our expected price times our expected volume. Well, if we have an expected volume of 1,200 and expected price times expected volume equals 2,400, then we have our expected price is, if we have revenue of 2,400, right? Expected revenue of 2,400 equal to price expected times our expected volume of 1,200, then expected price must be in this case, actually $2,000, but because we're expressing this in thousands. So $2,000 per surgery times 1,200 surgeries gives us 2.4 million in revenue. So that's where the static comes from. So the price expected would be 2. And then if we look here, you can kind of confirm that because flex is 2,600. Flex revenue is 2,600. We have price, right, is price expected times volume, 1,300. Well, 2,600 divided by 1,300 is 2, so PE is 2, which we already knew from over here. So that's how we get revenue. It's going to be the price expected, which is 2, times the number of surgeries, which was 1,300. And then finally, we have actual revenue of 2,335. Just make sure I've got that. 2,535, excuse me. 2,535. Just making sure I copied everything down because writing quickly. Okay, so our expected revenues are 2,535. We have price actual times the actual number of surgeries, which is 1,300. So we'll grab our calculator. price actual is going to be 2535 divided by 1300, or 1.95. So the actual price was 1.95 per surgery. So what about the flex for the others? So the question really is explain the flex. So I'm going a little past that. But so we have flexible revenue. We talked about salary expense, again, is expected price times actual volume. So what is expected price? Well, salary expense is 1,200. Expected price, well, we know what expected volume is. It's 1,200. And so expected price times 1,200 gives us 1,200. Well, that means if we divide both sides by 1,200, we get expected price equals 1, right? And so if we take the expected price of 1 times the actual volume of 1,300, we expect to see 1,300, which we do, right? Because so flex salary expense would be the price expected of 1 times the volume actual 1,300 gives us 1,300, which is what we see right here. And then next, non-salary expense. Well, non-salary expense on the static is 600. And again, price expected, or the cost per unit of non-salary expense times the number of surgeries, 1,200, divide through both sides by 1,200, and we get expected price of the non-salary expense per unit is equal to 0.5. To get the flex, we take the price expected of 50 cents per, or 0.5 or 500 per, times the actual volume of 1,300, and we get 650, which again matches right here. So that's where all that comes from. So that's part A. Part B says, determine the variances for each line of profit and loss statement, both in dollar terms and in percentage terms. So we're going to have a total variance, volume variance, and price variance, or management variance. Okay, so we're going to only go down to that level. So let's start with revenue variance is equal to revenue actual minus revenue static, right? So 2535 minus 2400 gives us a positive 135 positive variance, right? And the percent variance, so we're interested in how much more revenue, so the revenue variance, we're interested in how much more revenue did we actually get versus how much we thought we would get. So we're going to take 135, right, which is the difference between actual minus static divided by static, 2400, and that gives us 135 divided by 2400, 5.6% more revenue than we thought we would have. Now, when I do percent change, and in this case, I'm interested in relative to what I expected, I will take, so I typically, the way I tell my students to calculate percent change, right, the triangle stands for delta or change. I take new minus old over old, which in this case would be actual minus static over static. Now this actual minus static was what we calculated here, right? Actual minus static is 135. So that was what we put in the numerator, and then the denominator was the old or the static, which was the 2400. Right, so that's what we did. So I'm going to skip that step, this actual minus static step, and just take, as we go along, I'm just going to take what we calculate when we calculate the total variance and use that as the numerator. But understand, this is actually what I'm doing, and I'm kind of shortcutting it. All right, so now we want to decompose revenue variance into volume variance and price variance, right? So volume variance, next. New sheet of paper. So I'm focused on revenue. So volume variance for revenue. We want the two columns that allow us to compare actual and static volume while holding price constant. So here we have, between actual and flex, we have actual volume, price expected, price actual. So that doesn't work for us because the volume is being held constant. What we want to do is hold the price constant. So here the price is varying, but the volume is not varying. So we want the opposite. We actually want this one. We want to compare static and flex, because here we hold the price constant and we vary the volume. So we want volume variance. We want the two columns, we want to compare the two columns that allow us to show the variance between volume, the effect of the change in volume on revenue. So because we're doing revenue and we want our actual to be greater than our static, we're going to go flex minus static. So we want revenue flex minus revenue static. And so revenue flex is 2,600 and revenue static is 2,400, and we get a positive 200 outcome, right? And what's the percent volume variance? Well, that's going to be 200, the change, divided by static 2,400. So 200 divided by 2,400 is 8.3%. Now we want to do, next we want to do price variance, right? So in the same manner, price variance, we want the two columns that allow us to hold volume constant and vary price. And that's these two that we talked about a minute ago, right? Because actual and flex hold volume at actual volume and then vary price. And because we were varying price in order to get the price variance or the impact of the change in price on revenue, so we're going to take revenue actual minus revenue flex to get our price variance, and our revenue actual is 2,535, and our revenue flex is 2,600. So we have a negative variance of 2,535 minus 2,600 is minus 65. So a second ago, we calculated that the volume variance was, I want to get the percent first, so we'll do that in a second. All right, so then the percent change is going to be, so it's going to be 65 minus 65, right, for the change in variance. Now remember, though, what we're concerned about is change relative to static. So static is always going to be in the denominator. Right, this is static revenue. It's always going to be the denominator because we're interested in terms of percent change. We're not interested in percent change relative to flex. We're interested in the percent change relative to what we thought we were going to get. So negative 65 divided by 2,400 gives us minus 2.7, minus 2.7%. Um, okay, so we had, let's see, we had an overall revenue variance of 5.6% or plus 135. We had volume variance of 200 or 8.3%. Price variance or 8.3%. Price variance of minus 65 or minus 2.7%. If we add these together, we should get our revenue variance. So 200 plus minus 65 is 135. And then 8.3% minus 2.7% is 5.6%. So if we compare that to our original revenue variances, we came up with 135, and 5.6%, right? And they match up. So remember, volume variance and price variance are simply components of revenue variance. We're going to decompose revenue variance into those two aspects. But when we add them back together, they should add back up to the parent variance, which in this case is the revenue variance. All right. So moving on. Now we're going to look at expenses. So we're going to look at salary expense, non-salary expense. So salary expense variance is going to be, in this case, remember, now with expenses, we want static to be bigger than actual, because if static is bigger than actual, what that means is we thought we'd spend more than we actually did. So if static is bigger than actual, it means we projected a bigger number than we actually spent. Unfortunately, in this case, that's not true. So we want salary expense static minus salary expense actual to get our overall salary expense variance. So that's 1,200 minus 1,365, which is minus 165, which means we overspent on salary expense. So we spent more on salary expense, right, than we thought we would. So we actually spent 1,365. We thought we'd spend 1,200. So we overspent, which is why this is a negative number. Negative kind of is meant to connotate bad, right? So salary expense decomposes then into a volume variance. And instead of price variance, we're going to call it management variance, because it's up to the manager to control the price of the assets that we're using. All right. So salary expense decomposing into first into volume variance for salary expense. We want the two columns that allow us to compare volume variance or allow us to vary volume while holding price constant. And that's going to be our flex and our static. So again, because we want static to be the biggest and actual to be the smallest, we're going to take static minus flex. So we're going to take 1,200 minus 1,300 gives us minus 100. So 100 minus 100, or 100 of our overspending comes from an increase in volume. We overspent by 165. 100 of it is going to come from our increase in volume, and then our management variance, which focuses on the price of the things we used. So management variance for salary expense is going to equal the variance from changes in price. So that's these columns, the flex and the actual, because it holds the volume constant and varies price. So salary expense flex, which is 1,300, minus salary expense actual, 1,365, gives us minus 65. If we add these two together, 101 and minus 100 plus minus 65, we get minus 165, which matches up to our parent salary expense variance number. Now, I didn't do the percent changes, so we'll just do that real quick. We had a 165 variance, so we take minus 165 divided by 1,200, which is our static amount, right? Because we're interested in, when we think about percent changes, we're interested in the percent relative to the original projection, or how far off are we? So we get 165 negative divided by 1,200 gives us 13.8%, roughly. Then 100 divided by 1,200 is 100 divided by 1,200 negative is 8.3%. And then 65 divided by 1,200. 65 will make it negative. Divided by 1,200 gives us minus, so likewise, minus 5.4%. If we add these two together, we ought to get that. So minus 5.4 plus 8.3 is 13.7. A little bit of rounding error there. We're pretty close enough. So they add up. So that is salary expense variance, and then we'll do the same thing for non-salary expense variance. Right, this gets a little repetitive, but it is that's the nature of the problem. So non-salary expense variance is going to equal, again, because this is a expense, we want actual to be smaller than static. So we want the overall variance is going to be non-salary expense static minus non-salary expense actual. So 600 minus 585. That leaves us a positive 15 variance. So we overall saw spent 15,000 less on non-salary expenses than we thought we would. So how does that decompose into volume variance for non-sal? Well, that's going to be, again, we're going to hold volume constant, hold price constant and vary volume. So that is our static and our flex. So we want non-salary static 600 minus flex 650. Is minus 50. So volume, we're up. We increased our spending on non-salary by 50 based on an increase in volume. So we should have expected based on the increase in volume, we would expect to have seen an additional 50,000 in non-salary expenses. We actually saw a decrease of 15,000. So that must mean that our managers did a good job controlling cost per unit. So let's see, let's look and see, where do we find volume constant and price varied? Well, that's the flex and actual, right? Because we have actual volume, expected price, actual price. So here's where you have your variance. So that's going to be flex minus actual, 650 minus 585. 650 minus 585 is plus 65. So plus 65 minus 50 is plus 15, which matches our non-salary variance, our overall non-salary variance. Now we want to calculate the percentages. So how much were we off from our original expectation of our non-salary expense? So our original expectation for non-salary was 600. We were off by 15. So 15 divided by 600 is 2.5%. So that means that these next two, the volume and the management variance, should add up to 2.5%. So we were off by, in terms of volume, we were off by negative 50. So 50 divided by 600, that's negative, is 8.3%. And we were off by 65 plus 65 divided by 600 for management. So 65 divided by 600 is 10.8%. And this was a negative. This is positive 10.8%. So 10.8 plus or minus, 8.3 is 2.5, which matches back to our overall non-salary variance. So those all match up. The one we didn't do so far is profit variance. So we can do profit variance fairly quickly because we're really only interested in overall profit variance. So profit variance is simply actual profit. So profit actual minus profit expected. So we had 585 minus 600. So we were off by 15. And we thought we would have 600 in profit, our static. So minus 15 divided by 600 is we were off by negative 2.5%. So our estimates missed our actuals by 2.5%. So Part C asks, what do Part B results tell Brandon's managers about the surgery center's operations for the quarter? All right. So looking at expenses, we had an increase in expenses in part related to volume, right? All of our volume is up. And so that drove an 8.3% increase in salary expenses, a 8.3% increase in volume, in non-salary expenses. So those two things were up because of that. Our manager did not do a great job managing salary expenses. They underestimated salary expenses per unit by 5%, but they did a good job managing non-salary expenses because they were able to control and keep prices down on the non-salary expenses by 10.8%. So managers, so volume was a big driver for increased expenses. And the managers were doing a good job managing non-salary expenses, but not as good a job managing salary expenses. So they, and then as you would expect from the revenue side, because volume was up, we saw a similar increase in revenue coming from volume, right? Our volume variance. But our price variance was down. So again, we charged less than we thought we would per unit. That's what our price variance tells us. If we have a negative price variance, it tells us that we charged less per unit, even though we did more units. So we had an overall positive revenue variance of plus 135, that came from the increase in volume, which gave us 200. It offset the fact that we had a reduction in average price per unit of 2.7%.